And Java is basically a programming language which you can implement to program the applications. Yeah, yeah, sure.
No
Okay,
problem.
okay, okay, okay. So
Okay, thank you.
after completion or in the midway, some parts of have been covered. After covering maybe 50-60% of the syllabus or the course, we can do something. We can build an application, okay, using Java, keeping the database in the backend, so that
I think
everybody
for
can
that, understand. Yeah, that's a very good suggestion. Actually, that's very
so
very good.
everybody will get acquainted why we are doing Java, why we are doing DBMS,
But
what is
for
the
that,
importance of that
I
thing.
think what I think, I
Mhm.
completely agree on you. The your idea is to implement the things that we have just tried to learn, all the things like how they are implemented into application, how we can
Yeah,
use to out
because
our
actually
own
that is the
application.
ultimate target. Na ultimate goal
So
is to
for that we need few things actually. Like nobody today is agreed to do applications on character user interface. So if you are moving to
yeah,
swing, if you are moving to
obviously.
effects, then I think we can able to write very good applications.
We will do not a very huge application, a very
A
small
small application,
application,
yeah, some small
small
application.
application. That's why
We can
those
we can
parts, I think those parts will not be there in our syllabus. That is a swing and JDBC, all those things. But we can give them a hint that these
right,
are
right.
the part that are needed to build an application. Okay, so we can do that in some
Right,
extra
we can go
time.
for some
Okay,
applications like electricity. Your electricity bill also a small application. We can do that.
yeah, yeah,
Huh.
anything,
That's a
so
good
that
one. Good one.
they
We can take that.
they will get to know that where the in actual field where the DBMS lies and where the Java actually plays its roles. So we have the chance of showing you all that kind of thing. Anyway, please start, Sekantji. Thank you.
So I just want a confirmation from all of us who are here. Is it good to go? Like all are in the good time, good mood to start.
Here, bhai.
Okay. I'm just
Okay,
going
okay.
for a small review what we have discussed in the last class. And the important part is we have started discussing different data types available in Java. And as per that, other the discussion goes like we have two different types. One we are calling as primitive, second one we are calling as non-primitive. We are only focusing on primitive right now. In primitive area, we have three different categories. One which can hold numeric values, one which can hold non-numeric values. And in numeric values, again, we have two different categories. One category is which can hold only whole numbers, no decimal point. And there are some data types which can hold floating point numbers. In whole numbers, we have four categories. One is byte, second one is short. Can somebody spell out the rest of them? Can somebody guide me the rest of the process? Byte, short, then fantastic. In floating time, we have very good. In non-numeric, we have two. One is character and boolean, no string. String is not a primitive data type. It's a predefined class. We have discussed that one, right? And yesterday we have discussed very thoroughly about the whole number parts, and also we have discussed how to represent different number systems as a literal in integers, right? We can represent octal numbers, we can represent binary numbers, we can represent hexadecimal numbers. For representing binary numbers, let me tell you one thing. The people who are using Java 1.6 and the before versions, for them binary was not there. From Java 1.7 onwards, binary number system is there. Otherwise, you cannot able to represent binary numbers. So when you write a program where you have to represent this binary number, please make sure your Java version is 1.7 onwards. 1.7 more, not the previous one. That is not backward compatible. Anyway, today's session will start with a discussion for floating point numbers. You
Bye.
know the
Just a second. Bye. Just a
please.
second.
Done?
हाँ भाई डन, मैं रिकॉर्ड कर रहा था.
Okay. So as the name suggests, floating point number, as the name suggests, see previously what we discussed in a programming, while writing a program, there might be some time where I need only whole numbers. You can take few examples. Suppose I have to write a program for total number of audience present might be in a stadium, total distance might be whole numbers, like that. So in those cases, whole number data types are more than enough. But if we talk about different kinds of program in our real life, there might be some situation where we want to represent number like this, maybe 23.567, something like this. If you want to represent the numbers like this, then whole numbers like int, short, byte, long, all these data types will not going to help you out. For that, definitely we need some different data types which is going to help me. And Java gives me two different types. One is float, second one is double. These are two primitive data types which are responsible to hold numbers with decimal point. But there is a very small difference in between these two. We'll go through. But the similarities in both of them is they can hold numbers with decimal point, both of them. So we'll start with the discussion on floating point numbers. For floating point numbers, the first thing is it will require 4 bytes. But the thing is, please do not apply the concept of data storage of whole numbers in floating point numbers. Please don't do that. Otherwise, you will say the range will be from -2 to the power, it will be 31 to something like that. No, that will be wrong. Floating point numbers are completely stored in a different format. I think in COA, computer architecture, we have a clear-cut scenario of that. We are not going depth into that because we do not require right here. If somebody want, I can post it as a video and all so that you can learn. Otherwise, in our syllabus, we don't have to go to that depth. Only thing is, I need to understand what is the data type, what is the size requirement of float. Second one, what is the range of a float data type? Float data type can hold up to -3.4 e to the power 38 to 3.4 e to the power 38. This is the range. I think this is a huge range, right? There might be some friends who will be saying what exactly this E is. This E is nothing, only 10. If I write like 3, if I expand this one like 3.4 into 10 to the power 38 to rest, you all are you can understand this is the range. If I want a range in between 100% pakka, this is my cup of tea. I should take the variable of which data type? Float data type. I hope this is very clear, right? This is a simple thing. Third point, this is very vital. Third point is floating point number can have maximum 5 to 6 decimal places, not more than that. Not more than that. So if my programming requirement says I'll be okay with the decimal point up to 5.5 and max 6, then I should go for float. Otherwise, immediately I should move for what?
Double.
Double. Of course, since it is double, the memory requirement is basically 8 bytes. And the range -1.7 e to the power 308. It's a huge number. 1. Up to 1.7 e to the power 308. This is the range. And if I talk about the decimal places, these are 14 to 15 decimal places. So I think this is clear. When I should go for floating point variable, when I should go for double variable, right? Right. Now, I have a small doubt here, as usual. Doubt is, if I'm writing, see, if I'm writing 3.4 only, see, 3.4 is a value which can be represented using float, which can be represented with double, for sure, right? If I write 3.4 only, and if I'll ask all of you, can you please tell me 3.4 is which kind of constant? Is it a float constant? Is it a double constant? Yes. Remember, if we are writing something like this without any without any letter, anything, this will be treated as a double constant, double type constant, right? But if I am writing like 3.4f, now this f represents floating point constant. This f, either it can be small or it can be capital, doesn't matter, both are same. But if you are writing f, capital F or small f at the right side, then it will be treated as floating point constant. Similarly, at some people are very much interested in writing 3.4d, that this is also valid. If you are writing d, it is also double. If you are not writing d, that is also double. No problem in that. Absolutely no problem in that. I hope all these parts are clear, right? Fine.
Yeah.
Now, no, I have just started. A lot of things we need to, well, actually we should enjoy. Thing is, if I'm writing float a, now you need to tell me whether I'm writing a valid one or invalid one. Now tell me, this is valid or invalid? I'm writing 10.46. And what is the reason behind that? And if I compile this program, what should be the error? Exact error. Possible lossy conversion, double to float, right? Double to float. Excellent. So if I'm writing f, this is fine, isn't it? Great. Now, if I'm writing this only, I'm not writing in a decimal point. No, I'm not writing f also. This will be invalid, right? Okay. Can everybody participate? We'll enjoy. A lot of very good conclusion is there.
Hello.
So
yes, I'm hearing you.
Present in
Integer
float,
है,
right?
integer.
Sorry?
10 is integer, right?
I don't know what you're saying. I said
10
this is valid or invalid. I don't know anything.
It will be valid, I think.
I think it is valid.
Yeah, it's valid. It's valid. It's valid. No problem in that. It's valid. This is what called as implicit type conversion. We'll understand this concept in some other sessions. But yes, it is valid. No problem in that. I can store a lower data type. I repeat, I can store a lower data type constant in a higher data type variable. Definitely you'll ask me which one is higher and which one is lower. Whenever we are going for that, please remember this diagram. Byte, then short, then int, then long, then float, then double.
And double.
This is in increasing order. So I can store a lower data type constant in higher data type variable. Float is a higher data type variable. I can store a lower constant in that. No problem at all. No problem at all. Your Java compiler will take that response. Once we try to display that one, immediately I'll get 10.0. No problem. Fine. Okay. Now, what I'm writing here is 10.0.0x 1 2. Valid? Is it valid?
Not valid, I think.
Not valid. You cannot write like that.
Because
now,
it's smaller than. No,
not smaller.
That is hexadecimal, right? I mean, when you put X, it should be
Right.
hexadecimal.
It's hexadecimal. Okay, there might be some confusion if I'm writing like this. No problem. I'm writing.
It's zero.
Now, the thing is, this is valid or invalid?
I think that's valid.
It's valid, right? All of us? Think like that.
Yes.
Valid.
You're multiplying hexadecimal with float, right?
It's a valid. I don't know. It's a valid. It's valid or invalid.
But dot, what does the dot say? Dot means
Decimal point. Decimal point. All of says this is all of think like this is valid, right?
No,
No, no, it cannot.
I think
I
it
have
is.
I have said in the last session, the if we are representing any different number other than base 10, strictly it should be integer. It cannot be float. It cannot carry a decimal point. If it carries a decimal point, we cannot represent any number system except decimal number system. That's the rule.
It is
Fine.
invalid.
If I'm writing 10.34f, no problem. If I'm writing 0, see, tell me if I'm writing 010 point something, this is invalid.
Yeah.
This is not invalid actually. This will be treated as 10.11. This is not octal number. Our previous practice says if a number is preceded with a 0, that is treated as octal number, right?
Yeah.
But that is only valid for whole numbers, not for any other data type.
Okay. Okay.
See, these basics are very much required when you are writing program, right? So make sure you understand it. Let me tell you the difference between these two. If I'm writing this, definitely the result of this one will be definitely how much? If I print this one, this will be 10.11. No problem. Absolutely this. But at the same time, if I'm writing, float D equals to 010, can somebody tell me what will be the answer? What will be the value of D? $10.00, right?
10.
It's 10.00. Since you said 10.00, trust me, this is wrong. See, look at this. This is integer or decimal? This number is an integer constant or decimal constant?
Integer.
So I said integer is valid, decimal point is invalid. I have not used any decimal point here, right?
No.
So it will tell me like 8.0. Done. That is the difference you should be very clear about. Right?
I actually didn't understand this.
See, if I'm writing, tell me if I'm writing 010, this is an integer constant, am I right?
Yes, yes.
So the value of this one will be 8 because this is octal number.
Okay.
But if I'm writing, if I can store this one in a float variable, just we have discussed why I can write. Fine. If I'm writing this, I'll get 8.0, no problem. But at the same time, if I'm writing 010.11f, now this is no more a octal number. This is only a decimal number. So the value will be 10.11.
11f.
That is the difference.
Okay, so here basically the float is used to represent the decimal numbers, which actually just contain only numbers, and it cannot take hexadecimal values or any character based um, uh, symbols
Absolutely.
with
Absolutely. You're
that.
right.
And also in case if we represent float with any number without a decimal point, then it will
Correct.
convert it into the suitable representation, right?
Exactly. This is what I'm trying to say. Or in simple terms, as I said, different number system can only be represented through integer constants, not any other constant. This is the basic rule. This can only be represented through integer constant. If I'm trying to put a dot here, this is no more integer constant now. If I remove this, this is an integer constant, right? Fine.
Yes.
So float does not actually, float constant has basically not completed here. If I want to represent, remember, if I want to represent 1.2 into 10 to the power 38. If I represent this one in a floating point number, how I can represent? The answer, the process is very simple. I can write like float f is equal to 1.2 e followed by 38. This is one of the second notation, how I can able to represent a floating point number, right?
Yeah.
This is one way. Second way that has been introduced recently, I can have a number separator. I want to represent like this. I can, no problem. This underscore will represent as a number separator. Like we have 1,000 separator, 1 lakh separator, 100 separator, right? For our convenience, we are used to write something like that. Fine.
Like you mean like comma that we put to represent hundreds and
Correct.
ten
Correct.
thousand and so on.
Here, 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 comma is not there. Instead of comma, I can go for underscore. But remember, but remember, this is only valid for float, not for integer, not for, sorry, it is only for decimal point, floating and double, not for integer, not for any other. Fine. If I'll ask you, all of you, if I'll ask you, 0 divided by 0, answer is
0.
Is it?
Yeah.
A infinity?
Sorry?
0.
10 by 0?
0.
It will be 10. No. One
No.
minute.
By 0 by 10,
No,
0.
it's infinity.
10 by
1
0.
by
Okay,
equal
okay,
to
okay. Hold on,
infinity,
hold
right?
on. Let us not get confused. Let us do it.
10 by 0 is infinity, right?
Infinity, right?
Yes.
Yeah.
Okay. I don't know.
0 by 10 is
Should be
0. 10 by 0 is
No,
infinity.
1 by 0 is always 0, right? ऐसा मतलब infinity.
1 by 0 is infinity.
Yes.
0
So
by 1 is 0.
yeah.
Let's say I believe to Java compiler. I'll believe to Java compiler, right?
Okay.
If I'm writing 10 by 0, right? The answer will be?
10
Come
by
on, the
0
answer will be?
Infinity.
Now the answer will be an exception. It will produce an error. As far as my knowledge is concerned, it should give you an error.
Okay.
Give me a second. No. No, it's on runtime. It's not in compile time. So it says arithmetic exception divided by 0, right? Very good. If I write 0 by 0,
0 by 0 is 0.
0 by 0 is
0.
very good. I don't know. Same, right? Now,
Oh.
now listen to the queries. 10 divided by 0.0. Right? 10 divided by 0.0. The answer should be, come on, same, right?
Error.
It
Error.
will be
Same.
exception.
Arithmetic exception.
Where?
Infinity. Now, here one very good point to make note. This infinity is not an error. This is one constant. This is a decimal constant introduced in Java. We don't have only infinity. We have negative infinity also. You want to check? We can check that. But it says minus infinity, right? So why have discussed about these 2 points? Like we're talking about floating point constants like f, like d for double constant. Similarly, we have 3 more constant introduced in decimal point. One is infinity, means positive infinity. One is negative infinity, and one more constant is there. I'll tell you, one more literal is there. That is
0 itself.
very famous one. Yes, NaN. These are 3 examples. Plus infinity, minus infinity, not a number. These are 3 different literals introduced for decimal constant. So if
Okay.
in a MCQ it has been asked what is the value of 10.0, it is not an exception, not anything else. Please write it as infinity.
I
But
have a question
but
here.
yes, please.
I don't know if it is quite relevant or not, but
Uh-huh.
it just popped into my head.
Please, please.
We studied about recursion, right?
Uh-huh.
I mean, see, I'm new to this programming. We studied about recursion, and the recursion is the process where it keeps on repeating a function infinitely until there is a, what do you call that case? Something until there is
Base
a
base
base.
case. Base case. Yeah.
Yeah, base case, yes, base criteria, and until there is a base criteria it keeps on going infinitely. Now you told about a positive infinity and negative infinity, right? I mean, with regards to the negative part of the infinity, does it apply anywhere towards that recursion approach?
No, not at all. Not at all. See why all these have been made actually. When we go deep into Java, when we try to understand the exception handling and all, by writing 0 by 0, we are basically we are receiving some exceptions from Java compiler, Java virtual machine, and when we receive exception, we said this is abnormal termination. Means the program is not in the control of programmer; it is in the control of JVM. So
Yes.
as a programmer, of course, I'll get hurt. Keep the program is not in my control, right? So to help the developer in that manner, they have introduced few things, but all these things are pretty irrelevant in our application. Somebody going for some scientific calculation, somebody going for calculations into